Have you ever wondered what lies beyond our solar system? What mysteries are hidden within the vast, dark fabric of the universe? When we gaze at the night sky, we're only catching a distant glimpse, like a single grain of sand in an endless desert. The worlds that exist beyond the reach of light years remain largely a mystery. That's exactly why humanity launched the James Webb Space Telescope, to peer deeper into the cosmos than ever before. Among its groundbreaking discoveries, one in particular has stunned the scientific community. It's a finding so unexpected, it's rewriting what we thought we knew. Thanks to Quantum AI, new data from the James Webb Telescope has revealed shocking anomalies in the Kuiper Belt, structures or phenomena so unusual, they defy our current understanding of physics and space. Scientists are in awe. These findings could revolutionize our understanding of the outer solar system and the broader evolution of the cosmos. So, what exactly has been discovered? Let's dive in. Quantum AI has just revealed astonishing data gathered by the James Webb Space Telescope, JWST. The telescope has returned unexpected readings from the Kuiper Belt, a remote region beyond Neptune filled with icy objects and dwarf planets. Recently, Quantum AI, an advanced system powered by quantum computing, was tasked with analyzing this complex dataset. What it found took researchers by surprise: strange thermal signatures and unusual chemical compositions on several Kuiper Belt objects, KBOs. These anomalies hint at unknown processes, possibly involving exotic materials or unexplained energy sources that defy existing models of how our solar system formed. Thanks to its ability to detect faint, hidden patterns in vast amounts of data, Quantum AI made these discoveries far faster than traditional analytical tools ever could. Researchers are now rethinking long-held beliefs about how the outer solar system evolved. Surprising new data is reshaping planetary science and showcasing how quantum computing could transform our approach to exploring and analyzing space, making the distant regions of our solar system seem even more enigmatic. But what exactly is the James Webb Space Telescope, and where is it? Launched on December 25, 2021, the James Webb Space Telescope, JWST, is the most sophisticated and powerful space observatory ever built. It's a joint effort by NASA, the European Space Agency, ESA, and the Canadian Space Agency, CSA, aimed at exploring the universe with unprecedented detail. The James Webb Space Telescope, JWST, is designed to explore the origins of stars and galaxies, investigate exoplanets for potential signs of life, and peer deep into the cosmos to observe the early universe shortly after the Big Bang. Often seen as the successor to the Hubble Space Telescope, JWST features a very different design and expanded capabilities. Unlike Hubble, which mainly captures visible and ultraviolet light, JWST specializes in infrared observations. This enables it to see through dense clouds of cosmic dust and detect light from extremely distant galaxies, light that has shifted into the infrared spectrum due to the universe's expansion. Its primary mirror spans 6.5 meters in diameter, more than twice the size of Hubble's, allowing it to gather significantly more light and reveal much fainter objects. The telescope operates from a location about 1.5 million kilometers, roughly 1 million miles, from Earth, at a position called the second Lagrange point, or L2. This stable spot in space enables JWST to maintain a consistent orbit around the Sun. By remaining aligned with Earth, which aids in both communication and protection from the Sun's heat and light, the James Webb Space Telescope is shielded by a massive sun shield, about the size of a tennis court. This shield keeps the telescope extremely cold, which is essential for observing infrared light. From its unique position in space, Webb is delivering breathtaking images and revolutionary data that are reshaping our understanding of the universe. But where is the Kuiper Belt, and why is it so fascinating? The Kuiper Belt is a vast, donut-shaped region filled with icy objects, located beyond Neptune. It spans roughly 30 to 55 astronomical units, AU, from the Sun, where $1 is the distance from Earth to the Sun. Although it's similar to the asteroid belt, the Kuiper Belt is much larger, about 20 times wider and up to 200 times more massive. It's named after Dutch-American astronomer Gerard Kuiper, even though he didn't actually predict its existence. Building on his ideas, others eventually proposed, and later confirmed, the existence of this distant region of the solar system. The Kuiper Belt is particularly fascinating because it acts like a time capsule from the solar system's early days. It's filled with icy planetesimals, small bodies that never became planets. Due to their remote location and frigid temperatures, many of these objects are believed to be remarkably well preserved, holding vital clues to how the solar system formed over 4.5 billion years ago. Among the most well-known Kuiper Belt objects is Pluto, which was reclassified as a dwarf planet in 2006, largely because it shares its orbital zone with many similar bodies. NASA's New Horizons mission provided our first close-up of a Kuiper Belt object during its 2015 flyby of Pluto, revealing an unexpectedly complex world featuring mountains, glaciers, and possibly even subsurface oceans. Scientists are astonished by the Kuiper Belt's influence on the migration of the giant planets, as well as its potential to harbor undiscovered dwarf planets or even a much larger entity, often referred to as Planet 9. Investigating the Kuiper Belt not only helps astronomers learn about the formation of our own planetary system but also provides insights into how planetary systems form around other stars. The James Webb Space Telescope has made several groundbreaking discoveries that have both shocked and informed the scientific community. Let's dive deeper into some of these revelations. Here we go. One such discovery is the potential identification of a rare triple system. NASA's James Webb Space Telescope, JWST, has possibly detected a unique triple object system in the Kuiper Belt. This distant region, located beyond Neptune, is home to icy bodies and remnants from the solar system's early formation. This find is especially significant because triple systems, where three celestial bodies orbit each other in a stable configuration, are extremely rare, particularly in such far-off regions. The objects in question are believed to belong to the Kuiper Belt Object (KBO) catalog, and preliminary data from JWST's infrared instrument indicates the presence of three closely interacting bodies, as opposed to the more typical binary systems. This discovery was made possible by JWST's exceptional resolution and infrared sensitivity, which enable it to detect subtle movements, heat emissions, and compositional details from the distant, frigid reaches of our solar system. The proposed triple system consists of a primary object with two smaller companions, all orbiting in a manner that suggests a shared gravitational connection. If confirmed, this system could provide valuable insights into the complex gravitational dynamics and collision history of the Kuiper Belt, as well as offer clues about how small bodies formed in the early solar system. Triple systems are essential for understanding mass distribution, orbital evolution, and the effects of external forces in the outer solar system. This discovery also challenges existing models that mostly predict binary systems due to the chaotic conditions prevalent in this region. Additional observations and orbital analysis will be needed to confirm whether the system is truly a triple one. However, this potential discovery represents another significant achievement for the James Webb Space Telescope, JWST, and paves the way for further exploration of the distant reaches of our solar system. Recent findings from the JWST have provided groundbreaking insights into the geothermal activity of two dwarf planets, Ares and Makemake, located in the Kuiper Belt beyond Neptune. Previously thought to be cold and inactive, these icy bodies have now shown signs of geothermal processes. Scientists have detected methane ice on the surfaces of Ares and Makemake, and the analysis of this methane reveals isotopic signatures that differ from those found in comets. These unique characteristics suggest internal geochemical processes, most likely driven by heat from their rocky cores. Such activity could point to hydrothermal or metamorphic processes beneath their frozen exteriors. Just as Quantum AI started simulating how a black hole universe might actually function, something unexpected surfaced, an eerie, almost imperceptible anomaly. It wasn't visual, but vibrational. While the AI analyzed visible data, it was also processing immense datasets of raw signal noise, background fluctuations from the farthest reaches the JWST has ever observed. These weren't sound waves, but subtle, low-frequency distortions in spacetime itself. When Quantum AI ran this through its deep recognition layers, strange patterns began to emerge: rhythms, pulses, repeating vibrations that appeared across vast distances and at different points in time, yet somehow matched. Now think about this: if we are inside a rotating black hole, the curvature of spacetime wouldn't just affect how galaxies move. It could also generate a resonance effect, much like spinning water in a bowl produces circular waves.